Alright, question number 10. We're given a graph. Kind of hard to get the whole thing up here. And we want to evaluate the following. So f of negative 4. So normally you would plug it in, but since we don't have an equation, we're going to use the graph. This notation simply means that x is negative 4. Find the y value. So x is negative 4. Down here, the y value is also negative 4. So they give you x, you find y. Then part B, same thing. We just got a new number. X is 3. What is the y value? So you look on this graph. X is 3. We get a y value of 4. So now C wants to know inverse. Alright, so we don't even have the inverse, but because this function is one-to-one, like if you drew horizontal lines, it would only cross once no matter where, and vertical. So this is a one-to-one function, so we do know that it will have an inverse. Based on that, we're now doing the reverse order. So this means the y value is 1. What is the x value? So when you do inverse, it's backwards. This is the y value. Y is 1. So here's this order pair. Y is 1. The x value associated with that is negative 1. And you could simply graph this and draw the inverse, if that would help, like we did in the problem earlier in this section. This one is saying, okay, the y value is negative 4 because it's inverse. The y is negative 4. So find negative 4, and the x value corresponds to that is also negative 4. So you just got to find the ordered pairs. They give you x, you find y, or they give you y and you find x. Alright. Now number 11, it says select function B. Check the display options fx, f negative x, and show both equations. Complete parts 1 through 4 below. Use the interactive figure, left and right arrow keys that's needed to slide. Okay, so you have this graph of functions. This is A. So when they say select B, right here when it says function B, you have different ones. So you have different ones. So like if I did show equation, okay, it's showing me those. That's for A. But if I select B, I got totally different graphs. Okay, so different things going on. So you gotta be careful. Let me see. Let me get rid of. Okay, so that's the equation, and this is the graph. So it's a square root equation. Okay. And then the inverse is this one, it's x squared. Alright, so we have both those equations, and the first thing we want to do, let me actually write those down. So, and then I'll flip back over. F of x is equal to the square root of x plus 4, and then f inverse of x is equal to x squared minus 4. Alright, so I got those wrote down. Let's pull that screen back up. Alright, so it wants us to find the domain of f of x. Alright, so here's f of x. We have a square root. So that means we have to set whatever is under the square root greater than or equal to 0. So domain starts out x plus 4 has to be greater than equal to 0. We cannot take the square root of negative, so it has to be positive. Subtract 4 from both sides and we get x is greater than or equal to negative 4, meaning negative 4 and above. So in interval notation, since equal to, we have to do a bracket, negative 4 up to infinity. And if I did the same thing here, there's no problems with the domain, because I'm pretty sure they're going to ask that domain is going to be all real numbers. So negative infinity to positive infinity. We don't have square root or fraction. Alright, so domain of f, bracket -4, comma, to infinity, close parentheses. Make sure you get those endpoints correct. That will cause you problems. Alright, what is the range? Okay, so you saw this graph, the graph of this function right here, starting here at -4 and going upward. Alright, so it never went below the y-axis. So your range, and you can also get this from the parent function, your range is y is greater than 0, greater than or equal to 0. So we can do interval notation 0 to infinity. Okay, no shifts, no translations or anything. So our range is going to be bracket 0 up to infinity, and then close parentheses. Alright. And now domain for this guy, which we've already talked about, is going to be all real numbers. So negative infinity to positive infinity. Incorrect. The domain of f inverse. We just had x squared. Let me go back and make sure I'm not missing something. Oh, it's not x squared. We're restricted. It's not x squared. Okay, so domain is from 0, based on this picture, to positive infinity. So we don't go past the negatives. But if it was x squared, I don't know why that's throwing me off. It seems like it should be a little bit, that restriction. Normally we have a restriction, so that's what we're doing right now. This is going from 0 in the x direction to the positive infinity side. Okay. So not negative is going from 0 to infinity, the right side. You can see that from the picture. So 0 here, and we do want to put that in a bracket. It's going to be equal to 0. Alright, and our range, which you can also kind of see from the picture, this graph got shifted down 4. Okay, so this graph was like 1, 2, 3, 4 down here, and then going upward. So it goes from -4 up to infinity. So your y, this has to be greater than or equal to -4. So in the range is going to be -4 to infinity. What you'll notice when you do the inverse, okay, so this is worth pointing out. This was the domain. This was the range. If you interchange x and y, okay, you also interchange your domain and range. So what was your domain is now your range, and what was your range is now your domain. So the same thing happens when you do inverse. So that's worth pointing out. If you get one, you get the other for free. Okay, so this would be bracket -4 to infinity, close parentheses.